All right, this is a continuation of section 4.2 and 4.3 concerning symmetry. We didn't touch this topic when we first did 4.2 and 4.3 because we were focusing on the rules and how to apply them. But rotational and line symmetry are also part of those sections. So we're going to start with symmetry and talk about line symmetry. There are no official notes for this, so you just have to take some notes on some paper. Symmetry is where when you do something, it looks the same. There's some, people have symmetry. Typically, your left arm and your right arm are the same length. Your eyes are typically the same location, the same color, the same shape. Animals have symmetry. Usually the left leg and the right leg are the same length. And it's not always true, but oftentimes, like think of a butterfly, the wings are symmetric. Even to the pattern, they're the same. So, we're talking about line symmetry. Line symmetry, just to give you examples, let's use the letter A. Is there some place that you could take the letter A and essentially fold it either up or maybe fold it this way, and the shape would line up exactly with itself? Yeah, so if you took the letter A, picture it, and you folded it in the middle. Take the letter A and fold it over. It's going to line up with itself. If you fold it on this line, this vertical line, see how the left side and the right side match up? That's one line of symmetry. It has line symmetry and it has one line of symmetry. What about the letter B? Does it have any line symmetry? Is there some place you could fold the letter B so that the two sides essentially fold upon one another, that they match up? This one, you would take it and you would fold it up or down. Maybe fold it like this, along this line. It also has one line of symmetry. What about the letter O? Capital O. So you will have to use your imagination here a little bit, given my own handwriting, but you could fold it vertically, bumping the table there, vertically, and the two sides match up, or you could fold it horizontally. You won't be able to fold it along the diagonal. They won't match up that way, but you could fold it vertical or horizontal. We would say that this one has two lines of symmetry. So you will be expected to be able to identify and draw lines of symmetry for shapes. So let me do a couple of shapes. What about a square? Well, a square you could fold vertical. You could fold horizontal. But what about any others? If you happen to have ever done origami, the art of paper folding, to like make a paper crane or a hat or something like that, you're supposed to start with a square. And the reason for that is you can fold it vertical or horizontal, but you can also fold it along the diagonal and the sides match up. Or along this diagonal and the sides match up. This has four lines of symmetry. If you don't believe me, go get a piece of paper, cut out a square, and fold it, and see how it folds. What about a rectangle? In school, oftentimes you are, and I don't know when this started or where it started, but if I told you to fold your paper hot dog style or hamburger style, 95% of my students or more know what that means. So here, my paper right now, here, if I wanted to fold it hot dog style, I would fold it this way, make it long and skinny. If I wanted to fold it hamburger style, I would fold it this way. And when teachers have you fold your papers like that, you match up the corners, right? You check the corners, and all of the paper lines up perfectly. Whether you fold it hamburger or hot dog style, you would still check the corner and make sure the corners line up. And you see the edges line up? You can fold that rectangle one way or the other. Why don't teachers typically have you fold the paper along the diagonals? Have you ever tried that before? What happens when you fold it along the diagonal? Here you go. Folding along the diagonal. First of all, it's a little bit harder to fold. And it's not going to be perfect by any means. But you see what happens? Like, this is kind of left over and this is kind of left over. They don't line up. That means that the diagonal is not a line of symmetry because these don't line up. In order to be a line of symmetry, they have to line up, they have to match perfectly. So the rectangle has two lines of symmetry. But only two. All right, the next type of symmetry is called rotational symmetry. Rotational symmetry is based off of symmetry when you rotate it. Can you take a shape and turn it and have it match back up where it started? Now, anything has 360-degree rotational symmetry. If I took my paper and I turned it 360 degrees, one full circle, it would be exactly where it started, right? Think of maybe doing a cartwheel. If you rotate your body 360 degrees, you end back with your feet on the ground and your head in the air. So, 360 degrees doesn't count. Everything has that. We're looking for other rotational symmetry. So let's see here. Let's think of another letter. Let's do the letter N. A capital N. Now maybe you've noticed this before. If you take the letter N and you start to turn it, is that a letter N? No, that's a Z. But if you keep turning it right there, it's the letter N again. How far did we turn the paper? Well, you can see the word rotation. It's upside down. My paper turned halfway around the circle. A circle is 360 degrees. What's halfway around the circle? Well, half of that is 180. If I keep turning and I get back to the beginning, 360, well, I know that it had 180-degree rotational symmetry because halfway around the circle, it looked like the letter N again. Let's see if there's another letter. Let's try the O. There's the letter O. Start to turn your paper. Does it? Now here, it kind of looks like an O again, but now it's like wider and shorter. It's not the same O. So we want to keep turning. Right there. There's the O. 180-degree rotation again. Turned it halfway around the circle. So here, again, 180-degree rotation. Letters, most of the letters we have don't have a lot of rotational symmetry, but shapes do. So let's look at maybe the square. Now I'm going to say this is the top. I'm going to label it just so we can keep track. So I take the square and I start to spin it. Tell me when I get the square again. Now the top doesn't have to be the top. The top could end up somewhere else. But you see the square is flat on the bottom. Let me know, when do I get another square where the bottom is flat? Well, I turn. Right there. There's a square and the bottom is flat. So the top is now on the right side of the picture. So I turn, I keep turning, and here is another square where the bottom is flat. And now the top's at the bottom. So this is the halfway mark because the top went from the top to the bottom. Now I turn it again. Right here. Here's another one. The third turn. We have another square. The bottom is flat. Square. Keep turning. Right here, we're back to the original spot. So this did have rotational symmetry, and we were able to do this in 4 turns. So what we need to do is figure out the degree measures. And maybe you've got it for 4 turns, but I want to give you the process because some of them are a little more complicated. What you do is you take the entire circle, which was 360 degrees, and you divide it by the 4 turns. And that tells you that each turn was 90 degrees. So the first turn was 90 degrees. The second turn was 90 more. So what is 90 more than 90? 90 plus 90 is 180. What's 90 more? 270. And then 360. Now the catch here is you always stop at 180. And the reason for it is that I decided to turn my paper clockwise. I could have also have decided to turn it counterclockwise. So you stop at 180 because of repetition. So those get ignored. The square has rotational symmetry of 90 and 180 degrees. Let's do one more shape. A pentagon. I'm going to put a T right there for the top. Now this is not a perfectly drawn pentagon, so use your imagination just a little bit, please. I start to turn this paper. When do I get a pentagon where it's flat on the bottom again? Well, right here. There's my first one. There's my second one. There's my third one. There's my fourth one. And now I'm back. 5 turns. So take 360, divide it by 5. So 360 divided by 5, that is 72. So the first turn was 72 degrees. The second turn was 2 of those 72 degree turns, which would be 144 degrees. The third turn, add 72 to that, you get 216. The fourth, add 72 to that, get 288. After that, the fifth turn was the full 360 degrees. And of all of these, we only count the ones at 180 or below. So this has rotational symmetry of 72 degrees and 144 degrees. And with that, you should have enough information to go ahead and practice with your symmetry homework.